All right, well, everyone, welcome to this month's ZoomTRAK meeting. We have a full program today with 4 presenters, and we're looking forward to each of these. We're going to be talking about, Terry Moore's going to do it, talking T-TRAK, and then Lee Calkins is going to give the latest portion of his Farragut loop presentation. And KATO has a new big boy they've announced, and we're going to tell you what we found out about that. And then the big thing this month is we're starting a new series of presentations on Arduinos. And this first section today is an introduction to that series of programs, and I think we will all find this very, very interesting. So without further ado, we will kick off the program, and Terry Moore is up to talk about T-TRAK. Terry, take it away, my friend.
Talking T-TRAK. This month's presentation will be a little different. I use PowerPoint a little differently. My presentations are not sales forecasts, growth charts, or bullet point indexes. Mine are like the pages of a book. Yes, the text is my script. As I read the text, you, my audience, can look at the graphics to see what I'm talking about. You don't need to read the text. This month's pages are very repetitive, so even I won't be reading all of them. I'll just give the highlights. The graphics are detailed and need time to study, which we don't have here. My Talkin T-TRAK presentations are recreated as PDF files and listed on the NRail Tips and Techniques webpage. This will be posted, allowing you to read the presentation like a book. You can dissect the text and reference the graphics at your leisure. That'll be the best way to enjoy this. Okay, let's talk T-TRAK. The new large T-TRAK junctions must have a rail gap in the straight track between the curves. Here's why. When the only junctions we had were the original Steve Jackson junctions, we didn't have any problems. We had one big insulator between the two curves, great big open space. Nothing but scenery. The adjacent loops using those corners could be anything we wanted. DC, DCC, blue, white, blue, or yellow bus reversed, blue, white. No connection? No problem. But now we have large junctions with that wonderful added straight track between the curves. Now there is an electrical connection between the two corners, regardless of whether those turnouts are power routing or not. The blue, white rail of the yellow track, shown in red, is continuous. Both adjacent loops using those corners are connected together and must be the same. DC, DCC, blue, white, blue, or yellow bus reverse, blue, white, unless a pair of insulated unijoiners are installed to separate them, shown in the middle to prevent electrical faults. My favorite way of providing that required rail brake is the use of a modified double crossover that has a rail brake in all 4 rails. Because of that, a little more wiring is required. Why the double crossover? I use a pair of junctions to supply my 8-track yard loop. My yellow buses always have reverse electrical power connections for the pseudo blue, white condition. Considering KATO's double crossover in T-TRAK standard, the 2 outer blue rails do not have a rail brake in the center, as do the white rails and the rails making up the diamond, as shown. As a result, they cannot be used as layout blocking or DCC district separation. So, for my use in large junctions with the added straight track between the curves, I cut the outside rails in the center at the location of the factory cut. Those two cuts allow blocking and district separation if required, and allows the operations I will outline in this presentation. A little more wiring is required. Let me explain that statement. Each module should have red and yellow track leads to connect to their respective buses, although they may not be used. Due to the known electrical continuity break required in the yellow track and created in both tracks by the double crossover, power must be supplied on both sides of the break. Both red track leads can be connected to the same plug. One thing about cutting those two rails on the double crossover, when you do that, the double crossover itself becomes unstable and folds in the middle. So you'll have to be careful when handling those double crossovers after you cut the rails. During this presentation, I will show these three layout scenarios in various electrical modes of blue, white, white, blue, and yellow bus supply reverse, blue, white, blue, white. I will include double crossovers on the large junctions to show their benefit, or lack of, and show the concerns and benefits created by the added straight track between the curves of the junctions. A single row spine situation where everything is wired blue, white, white, blue. In this case, all four turnouts are useful. Trains can run straight through, avoiding the branch loop. Trains can take the first turnout to access the branch's outer track, or take the third turnout to access the branch's inner loop in the opposite direction, and exit back out onto the spine. None of those double crossovers are useful. Note the inner loop could be supplied from the red bus. I'll be talking about the yellow bus next month. Same situation with everything wired blue, white, white, blue, with double crossovers added to both junctions, but they are totally unavailable, just like the others. As before, all four turnouts are useful. Trains can run straight through, avoiding the branch loops. Train can take the first turnouts to access the branch's outer track, or take the third, as before. Same single row spine situation, but the branch loop is blue, white, blue, white. In this case, all four turnouts are used, since trains cannot run straight through to avoid the branch loop. Trains must take the first and last turnouts around the branch's outer track. Trains on the branch's inner loop cannot use the junction's turnouts to access the spine. Crossovers in the branch loop could be used to access the branch's outer track and subsequently the spine, depending on the direction of the trains. Again, the same design with double crossovers added to the junctions, available in one direction only. In this case, only one turnout of each junction is useful. Trains cannot run straight through to avoid the branch loop. Trains must take the first and last turnouts around the branch's outer track. The double crossovers of the junctions allow the red line trains to access the branch's inner loop and exit back out onto the spine. Crossovers in their branch loop could also be used. So you can see here, installing the double crossovers is only a half of a benefit. With all standard T-TRAK blue, white, white, blue wiring, the double crossovers, any crossovers, are unavailable. The turnouts to the curves allow trains to continue straight, avoiding the inner loop, or follow the curve to run on the inner loop. Trains may also leave the inner loop and follow the yellow tracks to the next inner loop or further into the layout design. Typical blue-white, white-blue situation where crossovers are unavailable, but because of the extra track on the large junctions, the two loops can be accessed that way. Another situation with the same blue-white, white-blue pair of side-by-side loops, you'll notice the double crossovers in the junctions are totally unavailable. Next, with standard T-TRAK blue, white, white, blue wiring to this end loop, adjusted to create a pseudo blue, white situation, allows any crossovers in the end loop to be used, allowing trains to cross between the red and yellow tracks of the loop. Notice also that the double crossover between the blue, white, blue loop on the left and the blue, white loop on the right can be used, allowing trains to travel from loop to loop. All four of the junction turnouts must be set to the curves around the inner loops. That stop sign shows you exactly why we need that electrical disconnect right there, why we cut the rails. And because of that, the straight through track that we enjoy is unavailable to us. Standard T-TRAK blue, white, blue wiring to this end loop, adjusted to create a blue, white situation, allows any crossovers in the end loop to be used, just like before. The double crossovers on the junctions can also be used, but again, only in one direction. Now, this is why I say the diagrams are going to need to be studied, because you can see the blue-white rails and how it all fits together. Now, I'm going to continue with this, and the best thing to do, again, as I mentioned before, would be to have a look at the PDF file from the website, and you can sit back and dissect what I'm saying and writing to the diagram and see just exactly how this all fits together. With a blue, white situation, all four turnouts will allow trains to access or avoid the inner loops. The trains can go right straight through because there is no electrical reversal here from side to side. But blue, white, around the loop, you can use the turnouts. But between the loops, the electrical connection is reversed and the turnouts are not available. Installing double crossovers on the junctions here, the double crossovers are fully available, just like all these around the outside of the loop. And like I said, this one here between the loops is totally unavailable. Single module row spine is red track exclusive and therefore can only be blue, white, blue. So the spine is out this way. Red line trains run around the end loop and back out the spine in the opposite direction. Due to the blue, white, blue standard wiring, the double crossovers are unavailable, but the turnouts to the inner yellow loop can be used depending on the direction of travel of the trains. Now, again, you can see here as blue, white, white, blue on the inner loop. Trains can run straight through, pardon me, but there's a bit of a problem. If your trains are running from left to right, they can go into the inner loop, but it would require a reverse maneuver to get back out. If your trains are on the inner loop and they are traveling in a counterclockwise direction here, they can leave the inner loop, but then it would require a reverse move to get back into the inner loop. Unfortunately, because of this electrical situation, blue, white, white, blue on the double crossover in the junction is totally unavailable to us. Otherwise, everything else I mentioned before works. And like I say, all of these other double crossovers, because of the blue, white, white, blue situation, are also unavailable. Here, excuse me, with a blue, white inner loop, all of these crossovers around the loop are fully available, but trains cannot go along the spine through the junction because of the electrical opposition here. There's that electrical cut again, so the trains can only go so far, and they shouldn't actually be in there at all. So just simply set the turnouts for the curves, and you can still get trains in and out of the inner loop because the other crossovers, I'm showing double crossovers. It's an easy way of saying that both left and right crossovers can be used. So you can use any crossovers to get in and out of the inner loop if you so desire. Here, again, with the double crossover installed on the junction, the access is only one direction. You can only go through this way. You can't go through the other way. Again, all of your other crossovers are fully functional. So this one here only has an operational benefit. This little diagram, there are 13 double crossovers on the following diagrams. Their locations are shown by the red ellipses. I use the double crossovers to illustrate how including them in the construction of the popular large junctions can be beneficial. Their locations elsewhere in the diagrams show that left or right turnouts could also be used or not. Now, this is something that you'll probably want to look at and take time with. There is a code down here showing just exactly what you're going to see on the next diagrams and what it means. The one thing about these three loops, if all three of them are blue, white, white, blue, it's basically the worst case scenario of this layout. As with all blue, white, white, blue wiring, none of the crossovers can be used at all. The best thing to do here is to operate trains on their assigned loops only, regardless of direction. Trains leaving their loops will require reverse ops to return. Although this is the easiest layout to wire, actually they could all be supplied from just one bus, the red bus. It is the most restrictive and least fun to operate. The following examples are far more fun, but you must keep your wits about you as you lay the buses and wire the layouts. with only the middle loop wired as blue, white, white, blue. 3 crossovers are unavailable, and 3 others can be used in one direction only. So again, as we go through this, you can study this and just see exactly how this all fits together electrically. And sometimes this is where we start having wiring difficulties when creating layouts. You have to watch what you're doing with your wiring. So it's just something to be aware of. Here, blue, white on the middle loop, and the situation changes. Here, blue, white on all 3 loops, and the situation changes yet again. Now, although these crossovers are available in the directions indicated, you may wind up with opposing trains on the same tracks. So if you're going to be doing something like this and wish to use the crossovers to get to and from the various loops, there may be some railroading involved that you'll have to be aware of. Next month, the yellow bus, the real cause of many wiring problems. No, not that yellow bus. Thanks for watching.
Our next presenter is Lee Calkins, who is an NRail board member. And if you've been following our past ZoomTRAK meetings, you've already had a good introduction to the Farragut loop that Lee is building, and he's going to give you the latest update. Go ahead, Lee.
Hey, welcome to ZoomTRAK today, and welcome to the present 4th part of the Farragut loop. The part that I'm going to present today, actually, I was looking through my photos. I actually did this a year ago, so I'm way past what you guys are going to see today. The loop will be operational and at the Reno N-Scale convention, and then parts of it will also be down in Dallas, and I will be at both locations. So if you want to come see the loop or parts of the loop, stop by and see me. I'll be with the Fremo N layout at Reno, and I'll be with the Operations Roadshow layout, Fremo N layout, at the convention in Dallas. I won't be at the train show in Dallas. So we're looking at the topside rough-in for Fremo N for Farragut loop. Here's just an overall view of what the loop is supposed to look like. This is the blueprint that is hanging on the wall in the museum that is currently at the Farragut State Park. So if you remember last time, this is our diagram. This is what we're going to go over. We're going to go over attaching tops to the loop, laying out the track, roughing in scenery, preparing for track, and adding in the roadbed. If you remember last time, this is what the loop looked like when we left it in our last presentation. All the framing was up. Notice I did start 2 modules as a proof of concept as I was going, and then I went through and built everything else. So we're going to go through and talk about adding the tops next and getting the switches ready. So this is basswood. My friend Frank showed me this basswood, and I've been using it for all of the roadbed underneath all of my switches. So I purchased all my switches. I'm using Atlas code 55 switches because that is what the standard requires. Not that it's Atlas, but it needs to be code 55. Code 80 does not work for Fremo N. So everything I've got here is all Atlas track. I started laying out my switches on top of the basswood, marking them out. At this point of my build, I thought I wanted to use the Caboose Hobbies ground throws. They have a single pole double throw little switch in there. You see the brass right there, and that little brass right there is a slide switch, and it allows me to change the polarity of the frog. And so as I was going through and marking out all these switches, I was trying to get all of the pads ready for those Caboose Hobbies switch machines. Here's one of my yard ladders that I've got laid out, and I've drawn pencil around it. And I'm going through and just marking and making sure I've got enough basswood for everything. So there's the pads I was going to install at the time for those switch pads. Just laying them out on the module themselves to see how things look, because I like to lay things out before I ever start attaching stuff. So I know if I got to tweak stuff, I got to make movements or change what I'm doing. So this is looking into my little industrial yard. And there's the tracks that are going to go, just seeing how this thing's going to work. And that track does end up off the edge of the layout, like I show right there. Just an overview of looking at top of what the track layout's going to look like. There is one yard track that's stub ended, a passing track, and then that stub yard lead, which heads off to the industrial yard, which I'm not modeling. In the background, you can see all the electrical components, or some of the electrical components that are going to go into this. And we'll get into electrical on a later ZoomTRAK presentation. Just some more. This is looking at the main big 3-track yard that runs along the southern portion of the Farragut loop. More switches for the main portion. The top switch right there heads off to the other industrial yard as part of the loop. You see, I do have some of the foam installed, and we'll get to that here in just a second. Just laying out all these switches. After I got the basswood where I wanted it, I glued it to the top of the modules, and there I'm using wood glue for that, and I'm holding it down with cans of chili today. It's whatever I can find on the shelf that day I grab and use as weights. There's more chili holding down more of the basswood. So that's the final product after I get the basswood down. And on this one, I've already added foam and the roadbed. For the tops, I'm using insulated foam. It's 2-inch rigid foam. Locally here in North Idaho, I can get it at Lowe's or I can get it at Home Depot. I'm not sure where they have it. I know they don't have it in Southern California. You have to special order it. I'm not sure what other stores are over on the East Coast, but up here in the Pacific Northwest, we get it at Home Depot and Lowe's. And right now it's $52 a sheet. That's a price from today. I downloaded this image this morning. So I started laying out all the foam and piecing it in and cutting it to go around all the blocks that I put in. And those blocks were there at the end of the modules to keep the track straight and level. And I put full length 3/4 inch plywood underneath where my switches are going to be. So my switches are really solid and aren't going to have any movement in them. We'll just walk around the layout and look at all the foam. It's not cut to fit yet. As you see in the background, some of that foam hangs over. I went through later and I trimmed it all to fit. I've started a little bit on the scenery. I've got a video here in a minute that'll talk a little bit about the scenery that I shot after I worked through this. So we've got all the foam tops installed. I had some blue foam. I've got some pink foam. It's really the same stuff. I haven't noticed any difference between the two colors of foam. They act the same. I install all of my foam with clear household caulk. And I like using the caulk because it doesn't dry hard. It dries and it's still not rigid. It moves and allows the foam to expand and contract a little bit without creating cracks. And it works really good as a glue, but it doesn't penetrate. It doesn't eat the foam, and it also doesn't penetrate into the wood. So if I do make a mistake, I can get in there with a knife and I can cut it off and scrape it off without damaging anything. So there's my 6th corner, and I actually built that as a different module for a different module set, but there's the 6th one. All of my modules have a matching module that goes with them, so I can stack them face to face with end plates. I believe I showed that in the last presentation on how I did that. For the loops, I made myself a great big compass, and I hooked my tape measure at 24 inches away and put a screw in. And there'll be a better view here in just a second. There's my big compass I made. And I mounted that to the module with a couple clamps so I can draw my center lines for the tracks. Now for Fremo N, on curves, you need to have 4 inches of straight track. And I think I'm running about 3.5, almost 4 inches on these modules. And so that's what I'm marking out here is take a tape measure and a pen and a marker and mark on it. Now, when you're using a Sharpie, the Sharpie bleeds through onto the foam. Well, if you draw it on the foam and then you try to paint it, it does bleed through. So I have to be really careful and only use the Sharpie where I know I'm going to cover it with something besides just paint, because it does bleed through. I have another module that has got a couple layers of ground foam on it to finally cover up where the Sharpie's at. I started sketching out some of the scenery. This module is going to get a cut because in real life, the roadbed is elevated through here, which I'll talk about here in the video in just a moment. So just going through and marking out, roughing in scenery. I'd use big utility knives. They've got the 4 or 5 inch blade on them, and they're sort of flexible. And that's how I do most of my carving. Things come out really rough, but I give it a coat of caulk afterwards. And since it's not a paved area, it's out in the forest and out in the woods, a little roughness you don't notice because it gets covered in ground foam and trees and brush. And it looks really nice once I'm done. So that's another cut module. Just working my way around. This one is, the module is in a cut. And so there's some hills that are on the sides. And out there, those hills where the layout is cut, where the roadbed is cut into the mountainside, it appears to be 14 or 15 feet deep to the top, and the tops are usually flat out there. So that's 1 inch of foam for me, which works out really well. It keeps my scenery low and doesn't interfere when I stack these modules face to face. So now going through the little stub yard here and getting the scenery in and roughing in the foam. And once I've got everything roughed in, I go through with caulk and I lay down a bead of caulk on every joint and every seam and get it all in there. And then I start smoothing it out with my finger and get it everything filled in so that I don't have any cracks. And that's what it looks like after I get it filled in. This caulk is not a white caulk, it's a clear caulk. I also use it for putting down my track. I made a mistake on one of my first modules and used a white caulk, which looks really ugly underneath the rails, where this caulk is clear and you can't see it once it dries. So there's
81 participants.
There's a general overview of the layout. You see I've run a bead of caulk down all those purple lines for where I'm going to put in my roadbed. Just working around modules there. I've gone through, I'm using Woodland Scenics foam roadbed. Some people prefer to use basswood, others prefer to use the cork. I like the foam for whatever reason. I don't know
what that is that they're making there.
Bruce, can you mute them again? At the end of the modules, I use masonite to support the rails. It gives me a place to glue down my PCB ties I use at the end. Some guys just use cork there with a whole lot of glue to make the end roadbed really, really rigid. I prefer using basswood or masonite. So after I got all of the foam in of the roadbed, I went through and I started cutting out where my joints were and started installing pieces of masonite so that I had that sturdy end to mount the module, to mount the track to. And I continued around and did that at all the joints. There's 11 different sections here. So there's a lot of different joints I had to go through and piece out. Here's the 3-track wide one that goes down my big main yard. And there's a little single track one at the end. Okay, welcome back to another update on the Farragut loop. I'm doing wiring on the 3-track yard module right now. I've got the bus wires underneath it. I'll show you in a second. But right now we've got the scenery roughed in for the industrial yard. We went out the other day and took photographs and found that this section of track, although it isn't a yard out there, is in a cut the whole way, and the cut's about 14 feet deep. And it continues around this first corner, and then it goes into a fill situation. So we've got 2 modules here that do have fills on them. And then the 4th corner is got a road that'll come across probably right about there that accesses the main 3-track yard. Then this last corner is on a cut again, and that brings us around to the yard. So we've got the bus wires installed. I'm still waiting on my AC to DC buck converter. I also need a toggle switch for my auto reverser so I can bypass the auto reverser for when this isn't a loop and it's used in just a normal situation. So here is the loop. We've got roadbed on all the 45s that are down, and we'll continue. We got to cut the roadbed at the joints, and then cut it back 3/4 of an inch or more to put in my basswood or masonite that I'm going to put in to make sure that everything stays nice and tight and square at the joints, like right there. So we've got basswood for 3/4 of an inch there, and then we've got 3 ties, and those ties are glued down with Gorilla Glue, and then the rails are soldered to the ties so that doesn't move at all. So this is our update for today. Thanks for watching. Now, all of those, I've shot about 20 or 30 videos as I've been doing this. All those are available to view on my YouTube page. They're also available on the FreeMoen page. I've taken over 1,000 pictures so far, and they're also all available on the FreeMoen page. These presentations are lagging about a year behind. The next one's probably going to be in September. Showing some more pictures of just the track being installed. Getting ready to put the roadbed in. For the main yard, what I did is I installed the middle section of roadbed upside down so that the bevel was upside down so that I could push the outside ones in correctly, and it made me a flat surface to build on instead of having the ditches between. I wanted to forego the ditch in the main yard. Just another end view of it. The main yard is built actually so that the middle section will come out, and it can be used as a 5.5 foot yard instead of the full 8 foot yard. So after we got everything installed, I went through and covered it in a base coat of my favorite color. It's affectionately known as baby poop brown, for those of you that have had kids. Covered my little industrial yard all painted. And then I was digging through my box of things and found a passenger station that already had lights in it. This station was made by a friend of mine who passed away several years ago, and I'm going to put it on our loop here as our passenger station. Another thing that I'm adding is a caboose campground. I've got a total of 7 cabooses that I will be installing. So again, thanks for coming and paying and watching today. And that is the end of today's update, and the next one is probably September, October.
Thank you very much, Lee. Interested in following along as that progresses. All right, the next thing we're going to do is Bruce is going to talk about the KATO Big Boy. And as I told you earlier in the day, I do have some Mother's Day obligations this afternoon. So at this point, Bruce is going to take over as our moderator, and I'll see you guys next month. Have a good one, and don't forget Mother's Day tomorrow. Bruce, you're up.
So KATO has been busy. They've had some personnel changes, and they've been releasing a lot of new products. And of course, the one that has gained a lot of interest is the Big Boy. And so we've got a couple of slides. I'm going to go through these real quickly because we're running a little late. But just thought there's a couple of interesting points here in this. We will this is KATO's slide set, and they talk a little bit about the history of the Big Boy. And of course, when it was restored in 2019, they started doing some fan trips, and there's been a lot of interest in this engine. And I think this may be the 3rd manufacturer releasing a Big Boy. So there are some unique things about this. For starters, I'll just run through these bullet points and then show you some pictures. 2 motors that drive each section, independently, can navigate 11-inch radius curves, and pickup is from both drive sections and the tender. And we'll talk about availability in a minute. Here is some data on the model itself. KATO does have these slides available, so if you want to go through and look at the data more closely, you can. The interesting thing about this is the minimum curves again. And here you see two engines on the 11 and 12 and 3/4, 12 and 3/8 inch. I believe this is these are the curve pieces with cement ties, and you can see that clearly the engines clear each other. Here are the two separate drive sections with independent motors and flywheel. Also, something that can be challenging is the headlights is out on the deck, but they actually have an operational tinted headlight out there on the deck. Some more detail information. The rivet detail on the firebox and the big boy chalk lettering on the smoke box, and the builder's plate. Preventing derailment. Basically, they've gone ahead and tried to design this so that this engine will track really well and won't derail on joints or specifically turnouts also. At this point, we have the coining press rods make realistic appearance. Rear piston cylinders make two separate parts to allow vertical movement of the rear drivers. And the close coupling of the engine and the tender. The prototypical tender construction. Now, the one thing that's interesting is how they handled that rear wheel, which looks like it's normally one piece, but they actually have it divided into two pieces, which helps with allow it to navigate that 11-inch radius. The decoder, if you get the decoder version, is in the tender, and the wiring is in the drawbar between the engine and the decoder to drive the engine and also pick up power. And finally, here are the list prices. Availability on the first version, that is the analog version, should be later on this month, in a couple of weeks. For the DCC version will be available in June, and the sound version will be available in July. And that's about all that I have for you. If you have questions, feel free to post them in chat, and we'll pass them on to KATO. I guess we will now move on to our next presentation, and we've got Thomas Steffens with us, and I'm just going to go ahead and turn it over to him. He is an HO person, but he also does some N scale, so he has volunteered to do an introduction to Arduino, and we really appreciate him taking the time to join us. So I'm going to ask Tom to unmute himself, and I will turn it over to him.
So this is just a quick and dirty overview. I put something together pretty quick, and I'll go over what they are, where to get them, which ones to use, how to get add-ons, and go through some examples. And I've got a separate presentation that I don't know if I'll go all the way through, but that shows how to do control panels using various techniques, including Arduinos. So what are Arduinos? They're little bitty single board computers that you can program. And here's a couple of examples. The one on the right is called an Arduino Uno. That's the original one that came out 15 or 20 years ago that started all the Arduino stuff. On the left, there's an Arduino Nano. That's the blue part, and the red part that it's in is a breakout board. I like the one on the left with the breakout board because there's more pins to use. On the Arduino, on the Uno, you've got plenty of pins, but you've got a pin, you need a ground. There's only 2 or 3 grounds on there. So you've got this one ground coming out to a ball of solder with 14 wires coming out. And I don't like that. On the red, the blues are the ones with the signal. The red is the power and the black is the ground. So every signal that you're dealing with, you've got the signal, the power, and the ground. Both of these use 5 volts. I'm told that the new ones coming out are using 3.3, which will change a bunch of the stuff I use, but this is just the overview of what it looks like. Arduino.cc is a website out on the web, and I'll show you that in a few minutes. That's the place to start. It's got descriptions of each official Arduino type. It's got the download for the IDE, which you need. It's got information on software features, functions, procedures. It's got examples and code and stuff on everything you can do that's built in. And there's a ton of stuff. So this is the place that you would normally start. Adafruit.com is a place that I like. It's got lots of add-ons for Arduinos and Pis and other things. It's a good place to try new things with drivers and libraries. There's cheap knockoffs on eBay and Amazon once you get familiar with what you're doing, like shift registers. There's one you can buy from Adafruit for $5 that will let you get started, and you go buy 20 of them for $5 off of Amazon. And that second Adafruit is a link to the site. Let's see. To start, you download the IDE from arduino.cc. You may also want a good text-only editor such as Sublime or Notepad++. You don't want to use a word processor. A word processor adds a bunch of stuff to the text, like this is the font and this is the thing and blah, blah, blah. There's all sorts of extraneous garbage it puts in that the compiler doesn't like. You'll get an Arduino. You probably want to get a breadboard. Then you get an LED or some doodads and see Adafruit. You look at blink.ino. That's the basic, I'm going to make a light go on and off. You make changes, you load it, compile it and load it, and then see what the changes are, and then iterate from there. This is not something that you get out of the box, that everything's there, unless you get a kit and then you get parts that you can put together. Think of an Arduino like a baseboard for Legos. And you buy all these different colors and shapes and sizes of Legos and stick them to the board and you make stuff. But the Arduino itself is just a building block. The code is in sketches. It's called a sketch. It's .ino or ICO, I think it is. I never can remember that. Blink.ino. That's an example. You've got public data on all of these. There's a lot of stuff out in the public domain. Arduinos are open source, which means all the specifications on how to make one are available for anybody that wants to make one. So Arduino is actually the official ones are made in Italy, and all the clones are made from China for now. But when you look at blink.ino as an example, you've got public data at the start, you've got a start function, and you've got a loop function. You set stuff up in the public data, like what your pin numbers are, naming stuff and getting things set up, initializing whatever you need to do. The start runs once at the front, so you set up the initial conditions. And then from then on, you go through the loop again and again and again and again until you either unplug it or it dies of old age, or you do. So this is a classic example of a program that you set it up running and it just runs. You don't have to, unless you're actually doing some input for it, it just sits there and runs. So you edit the INO file, you do verify. That does a you can call it a spell check. It makes sure that you've got everything where they are and it's spelled right and the compiler knows what it is. And if there's something it doesn't like, it'll tell you. And then you fix that and you do it again until you do it. And then you do a verify, which not the verify, you do the compile and upload. And the upload compiles the code and spits it on the Arduino. And now the Arduino is running your code. And that's the only way to change what's on the Arduino is to modify an INO file and then do an upload. There's lots of how-to videos on YouTube. Just search on Arduino and pick one. In the past couple of days, I've seen about 5 or 6 that are pretty good. They go into the technical details, which I'm not really going to do much today because it's an introduction. Why do you use it on a model railroad? Well, you use it for light effects. I'm working with one guy right now on one of my clubs. He's doing a hotel and he's doing individual room interiors and he's putting a light in each one. And we're going to connect that up to an Arduino, and the Arduino is going to turn the lights on in patterns. So it's not just all the lights on. You know, you cover up the photosensor and lights start to randomly come on until they're all on, and then you let go and then they come off randomly. So it's not just one on or off. You can automate and get light effects. There's a couple of places I know that use Arduinos to run welding lights, you know, random flashes of blue and white, and it looks pretty good. You can do automation with JMRI if you're using JMRI, which I like to do. You can use panel logic. I've got my second presentation, which I'll make available, is how to do a panel to control various layouts and stuff. It's not so much useful for T-TRAK, but if you've got a home layout or a club layout that you want to control stuff with a control panel instead of reaching over and knocking 3 trees over to get to the switch, it shows you how to do that. You can do turnout controls with servos and relays. I've got a code for a speedometer that you can put in anywhere, and it shows you how fast your locomotives are going by. And there's an in-scale version and an HO version. And that's the quick introduction. So anybody got any questions so far? Here's the Arduino website. And when you look at the original coming in, it talks about the hardware. Here's all the hardware that are available. There's nanos, which is what I like. These are small enough to go almost anywhere, but they're big enough that you don't have to have a magnifying glass to deal with them. There's the Maker family, which a lot of the 3D printer folks use. And then there's the Classic family. This is where the Uno came from. This is how they all started. And there's a lot of add-ons that fit on top of these. They call them shields. So you stack them up like pancakes, and it does this and that. And there's about a bazillion different varieties of those. It also has the software. So this is where you get the IDE. That's the program you use to program it. I'll show you how that actually works in a minute or two, but here's where you get it down is Windows, Linux, Mac OS. Being open source, there's options for Linux and Mac OS, which I don't really use, but so there's all these things you can do on that. That's where you get that. And over in the documentation, there's all sorts of stuff in the reference. If you think of an Arduino as the base for Legos, these are all the different colored blocks. So you've got digital read and write, you've got is alpha, you've got analog read and write, you've got shift in, shift out, random, etc. you can mix and match and do these. And when you look at one of these, like digital read, that shows you the example. It tells you how it works. And then it shows you an example code. So it shows you examples of here that you can copy and paste and share. That's one of the good things about open source, is that you can share stuff and it's okay. They don't come pull you off and say, no, that's mine, you can't do it. So here's the infamous blink code, which I mentioned earlier. It's just you set this and that. You say, I want the modes. I want to read this one and write that one. So you can look at it and see, here's the basics of how it works. So any questions on that so far? And I'll be going into more detail on what these are. So here's another website with Adafruit. And here's an example of they call it a 7-segment 4-digit display. I use this to do the output display of miles per hour on my speedometers. So it'll tell you how many miles an hour it's going. And when you dig down through this, it shows you what it is. It tells you it's got a backpack, so it's using I2C. And then it comes back and it's got some really good examples down in here. So detailed solder, detailed tutorials on how to solder it, very nice library, etc. So not only does it have the hardware, but it's got all the information you need to get it to work. And I've got several of those working, etc. And there's all sorts of stuff on this guy that on Adafruit. They've got sensors, they've got LEDs, they've got any doodad you can think of, plus a few. And so now let's see what stuff looks like. So I'm going to go over here. Let me see if I can open this up. So I'm in a folder here called 00 blank, and there's a blank.ino file. That's a sketch that works on the, it's the blank sketch. That's the bare minimum, doesn't do anything. So I'm going to double click on that, and the IDE is going to open up. And here it says, not now, there's setup and loop. That's just the bare minimum, it doesn't do anything. That's the framework for everything else. And if I go over here and do the blink slow with serial and click on that, that's a different script, different sketch. And let me maximize that. So it's got, here's a setup, and you start with some serial stuff to print out. You set the modes for the pins, LED pin high, and you set it high. And then on the loop, you just set it high, wait 2 seconds, set it low, wait 2 seconds, set it high, etc. And if you click on the verify over here, it goes through, and on the output, it shows you a whole bunch of stuff that you don't need to know what it is, unless unless you do something nasty. So I'm going to go here and I'm going to put, let's see, where am I going to put that? I'm going to right here, I'm going to add a character. So that is actually, I'm just going to type error. And if I then do the verify, it gets, it says, oh, no, I didn't like that. Here it is. Here's where the problem is, go fix it. So you go out and you look and see, here's what it says it is. It's not declared, which means it's just nothing. So you delete that back and do another verify, and it says, okay, everything's fine. And now when you're ready, you do the upload, and that will upload it to your Arduino. Let's see, this computer has been doing some weird stuff. So let's make sure I've got those correct. And we'll see if it lets me upload this time. There we go. Okay, so that was a successful upload. So I have now taken on my Arduino and I've replaced what was on there as the code with the sketch I just processed. And let's see, I don't think I can do that. I can show you in a minute the Arduino I just programmed. But now he's sitting there and he's doing a blink and blink and blink. And on the serial monitor, that's the serial thing I put up there. It is suggested that you do this on all of your sketches. Put something with a serial, set up serial and spit out a string that says, here's what it is. I'm going to restart that Arduino, and now it pops that up, and that's all it's doing, but it's telling me that this is what it was when it was made. It was in an LSR Division 1 meeting. It was on 3/11 of 23, and here's the name of the thing. So I know that's what's on there. Without this, you have no idea what code's on there, and the only way to know what's on there is to replace it with something new, which may or may not be what you want to do. Let's see, that's the base on that. Let's see. Oh, how do I get this out of the way? Oh, there we go. Okay, so I'm going to close this and I'm going to close that. And here's a blink faster. And you double click on that and it opens up. This is from somebody else's how-to presentation that I just sort of lifted. It's all open source. So there's blink faster. So he's got an on time and an off time. He's setting it up, and then he's doing the digital write low, setting out a serial output. So that's what he's doing. And then he's doing a delay with an on time or an off time. So he's got two different times he's using as seen up here. And that's the base of how you get an Arduino to work. Now, how do you get it to work with things to do something useful? Let me pop up my other presentation here and show you some of the things I've used Arduinos for on our layout. So this basically goes on how to use a panel. Let me dig down through here on why Arduinos are cost effective. When you look at the SC8C, that's $132. That's in dollars to control 8 turnouts. A DS52 does $28. NCE switch, it's 35. Switch 8's 83. Latching relay is $20. A DPD switch, which is just a switch toggle that you throw, is 50 cents, but that controls 1. In Arduino, under $10, it's $5 per turnout with no limit. I mean, you can just, In fact, it's normally less than 5. So Arduinos can be cost effective if you're willing to learn how to do them. There's direct wire with the D, there's delays, latching, delays, DCC controls. That's the most expensive part. And LCC is the new kid on the block, and it's twice as expensive as anything else. So here's controlling turnouts with an Arduino. I like the nanos because I've been using them for some time, but there's, pick the one you like. You need an Arduino. There's a breakout board or a shield if you need one. There's wires and connections. I use DuPont crimps. I like those. You can use Molex if you need to. There's relays. I've got some examples of those. You wire relays. They're the same as, you wire them the same as direct switches. You just wire to the relay instead of the switch. And then the Arduino can control as many relays as there are pins. And with a shift register, you can take 4 pins on the Arduino and do any number of multiples of 8. Here's the 2 relay types. They're both 5 volts. I think the blue ones down there, There's 12-volt versions, but I don't like those because I control them with the Arduino at 5 volts. The 5 volts, they come as a sheet, and you break off the ones you want. And then the ones on blue, you get those from eBay, and they come as 1, 2, 3, 4, 5, 12, 80. There's not 82, but there's a whole bunch of options in there. There's position lights, which are bicolor LEDs. If you need more than one, you can use I2C. I've got some examples on how to use that. Here's a control panel I have, and you can see me in the background taking the picture. I didn't realize that until I looked at the picture. But there's 8 buttons there, and that routes the train into one of 8 yard tracks. And there's 7 switches that controls, and you don't know which switch you need. You just push a button and it goes to that track. There's the inside of the panel, and you can see on the left, there's the back of the LEDs. On the right there is the Arduino, and then hovering sort of in space there is the shift register. There's 8 tracks, 8 LEDs, 1 shift register. It takes 4 wires off the Arduino. And here's the close-up of the Arduino and the shift register. Here's the master panel that they all connect to. Note the relays behind the wires in the center. That's those yellow relays that I mentioned. The black and white are the tortoise control lines. That goes out to the tortoise controls. The double pair red, white, green, white, that's the I2C lines that go to the slave Arduinos. And the red and white are the power lines. Plus is red and minus is white. So this one panel here controls 2 of those. But you could add 3 or 4, etc. And you'd say, why in the world do you want to use that? Well, here's our layout that these are on. And you can tell that there's an outer side and an inner side. There's inside. And if you look at the bottom of this, you can see there's the staging yard with 8 tracks. And that control panel that I just showed you is on the bottom down there, about where it says 15 in yellow. And there's one on this side and there's one on the other side. So you don't have to go to the other, to duck under to control the stuff that's on the inside of the layout. And if you look at the top there where it says cook yard, there's another set of these on the other end of that yard with one on the inside and one on the out. And if you look very carefully over to the right end of cook yard, there's a little junction there that goes from the bottom of cook yard across to the green line. That's the mountain. And that lets you go from the end of staging to either the yard entrance or going up the mountain. And that's a 3-position switch interface. And it's hard to get to that because it's inside the duck unders. So there's 3 panels on that. There's one on the bottom of the yard, one on the top of the yard, and one all the way on the right where it says Hartsdale. So from Hartsdale, you can control that from remote. And here's the master. Here's the junction panel 1 that's over near where it said Hartsdale. Here's the control next to the junction panel. That's since been moved into the main panel. And then here's the 3rd junction panel. They all control the same 3. You can see there's 4 lights and 2 buttons, and that's all you need. And then there's an Arduino behind each of those that is reading, did you push a button? Okay, I'm going to tell the master to do something. The master tells me what lights to show, and it shows you where you're routing on the panel. We use switchmaster motors. We're getting away from that. I've got the sketches available if you want to look and see how to do those. Let me close this out. That's the end of that. I have this as a zip file that I'll make available to go up, but here's all the images, and there's the presentation I just ran through really quick. Here's the sketch for the master. And here's the sketch for the slave. One's on table 42 and the other's on table 43. And when you double click on that, it opens up and it will show you how the slaves work and how the master works. So you can get a leg up on how to do remote one Arduino talking to another. So I pull in the wire. That's the I2C that has the blue, white, red, white connection between them. That's how the master talks to the slaves. It's got Arduino.h with just general stuff. It says here's number 9. Its max wire length is 2. The state base is there, etc. Some debug pins, root count, etc. Number of options for user input, etc. And then it goes down through and sets up a couple of things. That's for the shift register, sets up some root buttons, sets up some other stuff, and then does some stuff you need for the I2C. Here's the start, or the setup, begin, some print stuff so you can see what it's doing, sets up, and then it does the loop. And so he sits there waiting for you to push a button. When you push a button, he says, oh, a button was pushed. I'm going to send a message off to the master. And the master says, oh, you pushed button 2. That means it's going to the mountain. So blah, blah, blah. And it does his thing in the stuff. And all the slave is doing is waiting for the master to tell it what lights to set and notifying the master if a button was pushed. And all the logic on controlling the turnouts and relays is actually in the master, and that's over in here. So, has anybody fallen asleep yet? And anybody got a question?
I have a question.
Yeah.
How big is your club in that example?
It's about
No, I mean people.
We currently have about 80.
Okay, so how many people of the 80 know Arduino?
About 2.
So you gotta have 1 or 2 experts, just like a club
Right.
would have 1 or 2 experts in 3D printing.
Yeah. I've been trying to get them up. When we moved I did some of these before we moved out of the warehouse about 5 years ago, and there were 11 of us then. No, 20. It's some low number, and I've been trying to get new. I've got 3 people that I think are interested that I'm going to be training on how to pick up where I left off. Of course, if you're doing on a home layout, you just need someone like Speed to come in and tell you all the stuff you're doing, or a friend. I also do locomotive decoder installs, and there's not many in the club that know how to do that either, but I'm trying to get that up. One of the problems with the using technology is you have to find the people that are willing to learn something new. And at our age, sometimes that's difficult, but we've got several new guys in the club that I'm going to be training up. So yes, that is an issue and a problem, but if you've got the right people, somebody wants to learn something new, there it goes.
I guess if somebody wants to get started, what would you recommend is the first step to take?
The first step to take is to go to Adafruit and buy an Arduino. And I think there's several kits up on Amazon for a starting kit. And you get an Arduino, you get a a breakout board, and you get a bunch of parts like LEDs and switches and stuff that you can play around with. That's probably the best way. And then go up on YouTube and just type in starting with Arduino, and you'll get 4 or 5 different really good technical step-by-step. Here's what you do to get started. Or drop me a question, drop me a line and ask me a question, and I'll answer it.
Hey, Thomas, I have a question. So how many digital input outputs and how many analog inputs do I get, say, on a basic Uno Nano? And what's the approximate price point for that?
If you buy it new from Arduino.cc, it's about $15. If you buy the clone from China, I was looking the other day, and they're basically about $2 each. I've got a list of breakouts on the Arduino Nano and on the Uno. You get like 13 digital pins and 8 analog pins. And that sounds like a lot, but they will quickly run out. But if you use one of the, there's several different doodads you can use to expand that. There's some things that are I2C. I happen to like the shift registers. A shift register takes, I think, 3 or 4 pins, depending on which flavor it is. And each of those shift registers will give you 8 pins, either input or output. So for digital pins with a shift register, it's, pick a multiple of 8, and that uses 4 pins. So here's the old school Uno. That's see, there's the pins. That's what it looks like when you look down on it. And here's what all the pins are. And this will tell you what each type pin is. Here on the A's, there's the analog, and on the left, there's the digitals. There is something called a Mega. There's the Nano, which I use a lot of. That's my preferred one. And I use digital 4, 5, and 6 to run the shift out or shift in, and that gives me as many as I want. There is something called a Mega, which costs a bit more. I think they're like 20 or $30 each, but you get much more pins. So much so that on the bottom they're in 2 rows. So basically, you pick which Arduino you want for the application you want. And if you need more analog inputs, there's some I2C analog input doohickeys you can get from Adafruit or the clones off of Amazon. Does that answer your question?
I have one more. I assume your IDE is on a PC and your connection is a USB cable, but your Arduinos are buried underneath your layout. So how do you get at them to do the uploads?
You position them so that they point down, and then you crawl under, plug in to your laptop or a long USB connection, and that's how you program them. So here's a picture of an Arduino running on a battery, and that's that's using a shift out to run 8 LEDs. And I think that's still, that's still running on my other camera. If you look at this guy, you see the shiny thing on the end there? That's the USB connection. There's one down on the left and one up on the right. And that's how they come from the factory. There's something that I'm using. There's an Uno with the USB connection on it. The
Is that
new
something you
Nano,
could-
pardon?
Is that something you could install on your panel so that you didn't have to crawl under there
sure.
to connect?
You could install it on your panel with as a let's see.
I'm thinking of the USB port to connect to
Yes.
the.
Yeah. You could install a USB port under there and connect it. The problem is that when you're programming, you need to select which port it's on. If you got 8 of them on a USB port, you have to remember which one's which.
Okay.
To go look at. But you could take one extender and extend it out to a plug that you can then plug in on the board. So you can work that out with the USB cables to connect to it. I've got one USB cable that's like 8 foot long that I use for programming under the layout. While my laptop is a safe distance away, and it programs just fine. So there's not really any distance detriment to it. I would say from working with the I2C stuff that if you're using some of the I2C boards, they need to be right next to the Arduino, not very long. I had a long cable on the original ones I did, and it was kind of flaky every now and then, which is why I went to using an Arduino on each end. The Arduino on the left there with the blue and the red, I can order that part in bulk on eBay for about $3 or $4. Any other questions?
Yeah, where can we hook up to this presentation to study it a little more deeply?
I'll figure out with your guys how to upload it. I'll probably I think I can upload it all to your Facebook page. If that's a viable option.
I don't do Facebook.
Oh, you don't do Facebook? Okay.
Create a video.
He's not the only one who doesn't do Facebook.
Thank you.
Well, in that case, drop me a line and I'll send you about 47 emails with the various parts that fit on email.
All right, thank you.
I mean, we can figure a way to get it to you.
Correct me if I'm wrong, but isn't this going to be on ZoomTRAK, going to be on YouTube at some point?
Yeah.
Yeah, so they can just get it off our YouTube
It
channel.
will be, and we generally post slides on the tips and techniques page, which we've now opened up to the public.
Okay.
That's good. I do YouTube all the time. Thank you.
Yep. Okay, I expect to get a link to say stick it up here, and I'll stick it up there. And I've got a bunch more in the can options like speedometer, one that you can use either with a track occupancy or a couple of IR switches, or even just a read switch or whatever. Very flexible, and it tells you how fast your locomotive is going by. The only problem is I have trouble with my European stuff because it's 3-digit miles per hour, and that sort of boogers up the display.
All right. Well, Tom, thank you very much. We really appreciate that. Just a reminder to people that the cars are now available. Special run 50th anniversary cars are now available in the store. There are a limited number that will be available, and then the final batch will probably be at the NSE convention if they don't sell out sooner. So head over to the store if you want one. That's the best way to ensure you'll get one, or get both for that matter. There's a price, special combined price for members. Thank you very much, everyone.
You're welcome.
I hope everybody's filled out the poll. We will see you next month. I believe it is June 10th. Is that the date?
Yes.
This month, okay.
Thank you all for the nice meeting. Good night for me. Bye.
All right. Good
Thank
night,
you, guys,
everybody. We'll see you.
and email me if you have any questions.
Thank you, Tom.
You're welcome.
Sorry I got in late, but it was a great meeting. I appreciate all that's done to put these together. It's good learning for a novice like me. Tom mentioned his email. Is that going to be on the website also, or in the YouTube description?
Tom, what's your email for those of us who are still here?
I just put it in the chat,
Okay, yep.
mclee5-rails@yahoo.com. And with that, I will bid you guys good day.
All right, yep. I'm gonna shut her down now. Thank you, everybody. We'll see you. See you next month.
Adios, amigos.